Hello everyone, today I will walk you through the concept of model evolution in machine learning. This is crucial step in ensuring that a trained model performs well not just on the data it has seen but also on unseen data. Let's break this information into two parts: journal model evolution and handling cases where error costs are unequal. Let's talk about the standard model evolution. This involves accessing how well the model predicts the outcomes using metrics like accuracy, precision, recall, and F1 score. Here are the step by step by process. First, we will see how to perform model evaluation using Python. Model evaluation is the process of accessing how well a machine learning model performs on unseen data. It helps ensure the model generalize well and meet the requirement of the intended use. Here's a step-by-step guide to perform model evaluation using Python. First, splitting the data. We start by the splitting the data set into a training set and a test set. This ensures that we test the models of on unseen data, simulating real world scenario. Second, training the model. For demonstration, we use a random forest classifier which is versatile and robust machine learning algorithm. Make predictions. Once trained, the model makes predictions on the test set and we evaluate those predictions. Now evaluating metrics. Metrics like accuracy measures how often the model predict correctly overall. Precision focus on the correctness of positive predictions. Recalls tell us how well the model identifies all positive cases. F1 scores balance precision and recall all for a single score. This matrix helps us to understand the model strength and weakness. As advanced evaluation, ROC, AUC score, the ROC visualize the trade-off between true positive rate and false negative rate. The area under this curve AUC quantifies the model's performance. A higher AUC means better discriminatory power. Now let's come to the code. We have install first necessary libraries, that is pip install scikit learn matplotlib pandas quit. Import libraries, then generate synthetic dataset, then split data into training and datasets, then train a random forest model, then make a predictions, evaluate the model, confusion matrix, then matrix, then print matrix, then ROC, AUC score curves, plot ROC curve, then cross validations, then print mean CV accuracy. Now we will run our code. Here you can see confusion matrix, ROC curve, false negative, false positive rate, true positive rate. Finally, cross validation is used to ensure the model is robust. It splits the dataset multiple times and averages the result to avoid overlifting. Now we will talk about the accounting for unequal error cost using Python. Now let's address situation where error has unequal cost. For example, in fraud detection, a false negative might be more expensive than a false positive. Class weight. One way to address this is by using weighted models. We assign higher weight to the class that has a higher cost of misclassification. Second, adjusting decision threshold. By default, models classify an observation as positive if the probability is greater than 0.5. We can adjust this threshold to minimize the overall cost. Then we have third point is custom cost function. We calculate a custom cost based on the confusion matrix and predefined cost for false positive and false negative. This ensures that our evaluation aligns with business objectives. Fourth one is we have this hyperparameters. Turning the cost using grid search, we optimize the case weight or other parameters to minimize cost and maximize performance. This approach ensures the model is aligned with real world requirement. Here we have code for this: accounting for unequal error cost in Python. Install necessary libraries, import libraries, generate synthetic data sets, then split data into training and test sets, then train a random forest model with class weight, make predictions, classification report, adjust the decision threshold, then confusion matrix for adjusted threshold, then custom cost functions, calculate cost, print total cost with adjusted threshold, total cost, and then grid search for optimal class weighted, then best parameters and scores. Let's run our code. Here you can see in the classification report with class weights, precisions, recall, F1 score support, accuracy with macro average, weighted average, and confusion matrix with adjusted threshold. Now, wrapping up to summarize, model evolution is essential to ensure that machine learning models generalize well and meet performance standard when dealing with unequal error cost. We can adapt our evolution methods to reflect these priorities together. These techniques help us build robust and business relevant machine learning system. Thank you. I hope you had understood the topic.